Hi guys, good evening. Can you hear me? Hello. Yeah, good evening guys.
Yes, sir.
Can you hear me?
Yes, sir.
Yeah.
Yes, sir. Good evening.
Yeah. So let us start session. Last class about interpreter and compiler discussed. Yes, previous class all these basics completed. Yeah, these basics were completed. Yes, today we'll discuss about Java features. Java independent of platform. Yes, today topic is about Java features in that Java is an independent platform. Yes. Independent platform. Yes. See, Java is an independent platform. Yes, what does mean? Yes, what does it mean? Let us see about this. What does it mean here? Java is independent platform. What does it mean? Let us see. Yes, here independent platform means independent of operating system. Okay, Java is an independent of OS. Independent of OS. That means independent of operation. Independent of operating system. Operating system. Operating system. Okay, operating system. Yes, independent of operating system. Independent of platforms, independent of operating system. Okay, Java program. Yes, Java. That means Java program. Java program can run on any ways. On any ways. On any ways. Okay, Java independent of platform means yes, Java program can run on any ways. Java program can run on any ways here. That's it, fine. Yes. Now here how Java made us independent platform. How Java made us independent of platform. How Java made us independent platform. Next immediate question here. How Java made us independent platform. This is question. How Java made us independent platform. Okay. This one we should answer. How Java made us independent platform. This one we have to answer today. Yes, for that purpose. First of all, let us see about exe file. About exe file. Yes. First of all, about exe file. About exe. First of all, let us see about exe file. First of all, about exe file. First of all, about exe file. Okay. Yes. Here, some question for you guys. Some question for you guys. Exe file. Simple question. Exe file prepared. Exe file prepared on Windows OS. Windows OS. Windows OS. Windows OS. Yes, can I run on Linux OS? So there's a question here. Yes, exe file prepared on Windows OS. Can I run on Linux OS? Yes, anyone can you answer this? Very simple question. Exe file prepared on Windows OS. Can I run on Linux OS? Very simple question. One second. Yes, exe file. Exe file. Exe file question is exe file. Exe file prepared in Windows OS. Can I run on Linux OS? Very simple question. Exe file prepared in Windows OS. Can I run on Linux OS? Yes, let me check your answers. Yes, Abhinay saying that no. Kalyan, yes, saying that yes. No, I'm asking about exe file, not Java. I'm asking about exe file. I'm asking about exe file, not Java. Exe file. Exe file prepared on Windows space can I run on Linux space? Yes. Almost everyone saying that no. Yes. Answer is no. Yes. Answer is no. Exe file prepared on Windows space can I run on Linux space? Answer is no. No. Reason. Reason. Yeah, reason. Exe file. Exe file. Exe file is a OS dependent. OS dependent. Reason exe file is OS dependent. Exe file is a OS dependent. Exe file is OS dependent. Okay. Next, immediately question: why exe file is OS dependent? 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 Yes, immediately asking this question here. Yes. See, exe file prepared on Windows space can I run on Linux space? No. Answer is no. Reason exe file is a OS dependent. Exe file is a OS dependent. Exe file is a OS dependent. Why exe file is OS dependent? Why exe file is OS dependent? Okay, to understand this, yes, exe knowledge. What is exactly exe file? Yes, about exe file. Okay, suppose for example, C program exe file, C program exe file prepared, C program exe file prepared, C program exe file prepared on Windows base, Windows base, then okay. For example, C program exe file, C program exe file prepared on Windows base, then then it contains, then it contains, then it contains, then it contains what? C program exe file prepared in Windows base, then it contains what? Let's see. Windows, C program, yes, C program, Windows based C program, opening C program. Let us, this is C program, okay, C program. Now backend, this is C program here, backend of this C program, yes, Turbo C, next bin, yes, what is name of the C program file here? Math.cpp. CPP and C both are same. Math.cpp. CPP is C++. Okay. Yes. .c.cpp both are same. .c.cpp. CPP, C++. CPP is C++. Okay. In CPP we can write C programming. Okay. C++ is a next generation of C language. Okay. Same. C program we can write in CPP also. Math.cpp. CPP and C language both are compiled working same here. CPP. So math.cpp. So math.cpp this is, yeah, this is C++ program. Math.cpp. So this is program. Okay. Now math.cpp backend. See here. See math.cpp. Yes. Let me delete existing something here. See, this is math.cpp. Right. So this is math.cpp here. Okay. Yes. See, this program I am compiling. Just I am compiling. Success. When compiled, yes, behind of this one file creates 5:44 p.m. Okay. 21/1. See, 21st Jan. Okay. 21st Jan. Yes, 5:44 p.m. Yes, one file created. It's an object file. This is the object file. See, check it properties. Math.obj file. That object file generated. So what is this object file here? Yes. What is this object file? See, this object file contains binary code for our C program. Just a binary code for complete C program. That object file object file dot obj object file contains binary code for our C program. Okay, fine. Next here there are libraries. Libraries are different here. These libraries also having its own binary codes. Okay, yes, stdio data has its own binary codes. Conio data has its own binary code. The library. So this is C library. C library. C library has its own binary codes. C library has its own binary codes. See this program wide main for this C program for this program. Yes, math.obj. This is a yes binary codes. Math.obj. This kind of binary code for C program. Binary code for C program. Okay, now run it here. When you run this here, yes. Yes, one more file created, that exe file created. One more file exe file created. Yes, how this exe file generated here? Yes, how? See what happens here. At the time of creation of exe file, the C compiler taking binary code for your C program. This is math.obj, binary code of your program. Next, binary code of library. Library also developing binary code. Binary code for library like stdio data, conio data. Those two libraries, right? Okay. Yes. See binary code for these libraries here. Binary code for these two libraries. Predefined library. The binary code already available. Okay. So your program binary code is a math.obj. Math.obj binary code for your C program. Next binary code for the C library plus binary code for OS library. OS also called as library. By linking all of these things, finally generating exe file. By linking all of these things, it generates exe file. By linking all of these things, generates exe file. Okay. C program exe file. C program exe file prepared in this ways. Then it contains here binary code. Binary code for C program. Binary code for C program. Binary code for C program. Plus binary code for C program. Binary code for C program. Binary code for C program. Next binary code for C library. Binary code for C library. Next binary code for OS library. Binary code for yes, it's a Windows OS. So Windows library, Win library. Binary code for Windows library. Yes, by linking all of these things here, generating exe file. Okay, see C program exe file prepared in this ways here. Then it contains binary code for C program. Yes, next binary code for C library, binary code for Windows OS library. By linking all of these generating exe file. So at the time of creation of exe file itself, that OS library links to the exe file. Okay, here what happens to Windows? Yes, Windows OS library. OS library, yes, Windows OS library, yes, linked here, yes, links with exe file. Okay, yes, see here that Windows OS library, OS library links with exe file, yes, at the time of generation only, at the time of generating, at the time of generating exe file, at the time of generating exe file, at the time of generating exe file, at the time of generating, yes, at the time of generating exe file. Yes, it's a static link. This is called a static link. It is called a static link. It's a static link. It's a statical linking here. Statically linking. Okay, statically linking. Yes, it's a static linking. See, at the time of creation of exe file itself, okay, at the time of creating exe file itself here, yes, Windows OS library, that OS library links with exe file. At the time of generating exe file, it's a static linking. See, previously we discussed some point here about OS. See, these last points. See, every program has to link with OS library before we start execution. Every program has to link Every program has to link with OS library. C program, or C++, Java, Hadoop, all these programs, Python, all the programs have to link with OS library to communicate with the hardware components. Yes, compulsory. Every program has to link. Every program has to link with OS library to communicate with the hardware components. Okay. In C language, what happens here? In C language, at the time of creating exe file itself, OS library, that Windows OS library links with exe file at the time of generating exe file. It's a statical linking. Statical linking. So this is exe file. This is exe file. Let me show one more example. Linux. Let us take Linux here. Let us see Linux also. Let us see Linux also. Let us see Linux also. Yes. Suppose C program exe file. C program exe file prepared on Linux base. Linux, then it contains binary code for C program, binary code for C library, binary code for Linux library, Linux based library. That's it. Let me show that practically. On Linux also I'll show practically. Yes, this Linux login. Demo user login, Linux system, Linux base. See, on Linux, Java also you can develop. Java application development Linux also. Okay. Yes, I'll explain. Yes, I'll separate. I will take separate class on Linux base here. How to develop Java applications on Linux base? We'll discuss separate class. Okay. See, this is Eclipse to develop Java applications. I'm using Linux also. Yes. In my work, in my office work, I'm using Eclipse on Linux base. Okay. Yes. See here. Yes, you guys don't think about Linux base. Just think about C program only. ls cd mn ram ls present working directory mn ram. Yes, test.c program. See here, gedit. Gedit is like a Windows notepad. Like a Windows notepad, in Linux also notepad is available. Gedit is a Linux notepad. Okay, test.c. I'm opening that file here. Like a Windows notepad. See that? Same notepad opens. Like a Windows. Looking like Windows. Okay. Linux GA this is. Okay. See. A equal 10, B equal 20, C equal to A plus addition, subtraction, multiplication of two numbers. This is Linux. Okay. See here it's a Linux. Yes, let us compile this program. Yes, Linux. Compilation. GCC. GCC -C. GCC means C language compiler. This is C language compiler. C language compiler. Now hyphens means compile option. Just only compilation. Test.c. Test.c. Compiling compiles. Okay. Now remove start dot delete it again. Now here C gedit test.c. Test.c. Suppose here some mistakes, for example, some mistakes. What happens? Yes, compiler checking whole program from top to bottom, right? Same point I'm explaining now. 1 second here. Today, once again, that compiler topic saved. After saving here, now compilation GCC -c test.c. See that all errors from top to bottom. See list of all that list, right? Compiler checks the whole program from top to bottom. Compiler checks whole program from top to bottom. Top to shows all errors. See 8th line error, 12th line error, 14th line error, 18th line error. Yes, 22nd line error, 23rd line error. Yes, all the errors from top to bottom. Compiler checks the all statements from top to bottom and shows all the errors. Same point. Same, right? Okay, yes. Now, let us correct all that mistakes. Semicolon. Yes, here. Comma missing. Next here. W quotation missing. Okay, next here. W quotation missing. Save. Control S saved. After saving, now let us compile it. Let us compile it. GCC, yes, -c, test.c, yes, compile. Still one more error. Still one more error. Printf, semicolon expecting. Line number 22. Line number 22, semicolon. Yes, here, this semicolon. Save. Saved. Okay, ls. Okay, GCC -c test.c. Yes, compile done. Not test.o file generated. Same like a Windows space. Windows space object file dot obj here dot o file. Here extension is dot object file. So what is object file here? What is the object file here? See, tested.o file. See this tested.o file. Tested.o file means object file. That object file contains binary code of this program. C program convert into binary codes and try to tested.o file. So tested.o file contains binary code for this program. Next, see std data has its own binary code. Std data has its own binary code. Okay, this is a library. This library file has its own binary code. Okay, yes, fine. Now, next step, creation of exe file. Now creating exe file. GCC -o. Yes, exe name is, let us say project is the exe name. Project is the exe name. Test.o. Test.o. Yes, that exe file created. This name can be anyone, project or any name here. Now running that project exe file. Yes, project exe file. It is addition, subtraction, multiplication. That's it here. So what happens here? See here, this name can be anyone. That exe name. Exe name can be anyone. Suppose I'm giving some XYZ. Yes, XYZ. Yes, XYZ. That exe file. Green color means exe file. So /XYZ. Yes, execute it. That's it here. So what happens here? At the time of generating exe file, see here, generating exe file. See at the time of generating exe file here. See GCC, C language compiler. C language compiler taking binary code of your program. Tested.2 contains binary code of C program. Next, binary code of C library. Binary code of Linux OS library. Linking all of these libraries, generating, yes, linking all this binary code, generating project exe file. So this project exe file contains what? Yes, project exe file prepared on Linux base. Project exe file prepared on Linux base. C program exe file prepared on Linux base. Then it contains binary code for C program. Binary code for C program. Okay, so binary code for C program. Binary code for C program, binary code for C library, binary code for Linux based library. That's it. That is finally exe file. That is finally exe file. Yes, even you can check it. What is this project exe file? Yes, Linux is a file command to check the type of file. Yes, see this project. File is a command to check the type of the file. File is a command. File is a command to check the type of exe file. Now, what's the type of this file here? File is a command to check the type of the file. What's the type of this project file here? Type of project file. See, executable file. Project is a executable. Okay, see this. Here ld-linux 8x86 s64 s4 dot. What are these? Linux OS library. Linux OS input output library. S4 dot means .so means is a OS library. .s OS library extension is .s. Actually, it's embedded C concept. In embedded C, getting all of these things here. Embedded C generally, embedded C developer, they will check all of these things like this. Okay, so this is Linux OS library. This is OS library. That Linux OS library linked to project exe file. Okay, even that exe file also you can see. Project exe file. See, open that exe file. You can see that exe file. Yeah, it will take a little bit time to open. Yeah, this is project exe file or the binary code. See, exe file, binary format, 0s1 format, that exe file. Yes, it's exe file, binary format. So this is exe file. Yes, binary format. 0 ones format, binary format. It's exe file. So exe file, exe file. So binary format, exe file, exe file. Okay. Yes, here Linux file command to check the type of file. Yes, file command check the type of the file. Yes, what's the type of project? It's executable file. Okay. See 64-bit executable. 64-bit, this OS is 64-bit OS. Linux OS 64-bit OS. 64-bit OS. See Linux OS. Linux OS exe file. This is Linux OS. Okay, this is Linux library. Linux library. Linux library is a part of that project exe file. That is exe file. Okay, yes. So that is about exe file. A C program exe file prepared a Linux web, then it contains binary code for C program. Yes, binary code for C library, binary code for Linux based library. That's it. So here exe file linked with OS library. It's a statical linking. Okay, statical linking. Yes, let us take one more example. Another example. Yeah, this is one example. Next, another example. C++, C++ exe file, C++ program exe file. Prepared on, yes, Windows OS. Prepared on Windows OS. Then it contains binary code for C++ program. Binary code for C++ program. Okay. Yes, next plus binary code for C++ library like iOS team.h, C++ library, binary code for Windows OS library. That's it here. Okay, that's it here. So here exe file itself, at the time of creation of exe file itself, okay, linked with OS library. Okay, so exe file, always links with OS library, links with OS library. Yes, it's a statically linking here. It is a statically linking. Statically linking means at the time of generating exe file itself, all are linked. Okay, at the time of exe generation itself, all are linked. So it's a statical linking. Right? Yes, what is exactly statical linking? We'll discuss. Wait, I'll explain clearly. What is dynamical linking, statical linking? Dynamically and statically. The difference, once you see the difference, you can understand what is statically, what is dynamically. Differences, once you discuss difference here, you can understand here. Just wait for some time. Okay, now here let us take some example. Test.exe file, for example, test.exe file. Okay, for example, test.exe file prepared. Yes, prepared on Windows OS. For example, test.exe file prepared on Windows OS. Then it contains yes, Windows OS library. That's it. Okay, now this test.exe file prepared on Windows OS. Okay, then it contains Windows library. Then it links. Okay, then it links with Windows library. Then it links with Windows library. Yes, how the test.exe file running at different platforms. Okay, now test.exe file, the test.exe file on different platforms. So let us see how it's working in different platforms here. Test.exe file on different platforms. Test.exe file on different platforms. Now let us take different platforms here. Yes, suppose your computer, suppose hardware. First of all, hardware. See hardware. Yes, on top of hardware. Yes, suppose Windows operating system. On top of hardware, Windows operating system. On top of hardware, Windows operating system. Okay. Yes. Windows OS with Yes, Win library. Win library. 1 second. Windows OS. Let us make sure. Windows OS with Windows library. Windows OS with Win library. Okay. Yes. Yes. Hardware. On top of hardware, Windows OS with Windows OS library here. No test.exe file. Placing it. No test.exe file. So when you're running on test.exe file, how it's working here? Test.exe, this test.exe file on different platforms. So test.exe file, test.exe file on different platforms. So placed on Windows OS. Yes, how it's working here? See, when you try to run test.exe file, what happens here? When you try to run test.exe file on Windows OS, now test.exe file running on Windows OS. When you try to run it, what happens here? Now this test.exe file, yes, it makes a call to Win library. It makes a call to Win library. Win library. Okay, the test.exe file, it makes a call to Windows library. See test.exe file on different platforms. See test.exe file prepared in Windows OS. Then it links with Windows OS library. Now test.exe with Windows OS library here. Test.exe file with Windows library. Okay, when you try to run test.exe file, yes, it will try to invoke Windows library. It will try to call a test.exe file prepared in Windows OS. So it's linked with Windows OS library. Test.exe file linked with Windows OS library. Okay, since linked with Windows library, it will try to call Windows library. It will try to call Windows library. It will try to call Windows library. Yes, it's available. Using that library, it communicates with hardware components. That's it. This is working of exe file is like this. Okay. So when you try to run that exe file here, it will try to call Windows OS library because linked with Windows OS. So calling that, right? Yes. Now same test.exe file, another platform. If it is another platform, what happens? Let us see here. Yes. Let us take another platform. Suppose Linux base. Linux platform. Next, Linux base. Linux base with Linux library. Linux base with Linux library. Okay. Same test.exe file. Placing a Linux base. After placing a Linux base, now try to run test.exe file. When you try to run it, what happens here? When you try to run it, what happens here? When you try to run it, what happens? So when you try to run it here, now this test.exe file, it will try to call Windows library. Reason, the here test.exe file is linked. Test.exe file is linked with Windows OS library. Test.exe file already linked with Windows OS library. Since linked with Windows OS library, it will try to call Windows library. But here is not available. Okay, now this test.exe file, when you try to run a Linux base here, it will try to invoke Windows library on Linux base, but not available. Simply fails. It's not available, it fails. Okay, now this test.exe file, it will try to call Windows library. Here it's not available. Different library available, simply fails. That's it. So that's the reason exe file is OS dependent. Let us take another platform. Yes, Unix platform, Unix base. So next Unix base with Unix library here, Unix base with Unix library, same. Now test.exe file, it will try to call Windows OS library. Already test.exe file linked with Windows library here. Yes, all are linked, established, all are linked. Since linked with Windows OS library, now this test.exe file, yes, it will try to call Windows OS library on Unix base, but not available. It fails. That's the reason exe file is OS dependent. So why exe file is OS dependent? Reason, it contains OS library. Exe file contains OS library. Simple reason. Exe file contains OS library. So why exe file is OS dependent? Yes, for this answer, yes, it contains. It contains OS library. It contains OS. Simple answer. It contains OS library. Since exe file linked with OS library, yes, it's a OS dependent. Okay, yes, see, since exe file statically linked with OS library. Okay, OS library. Yes, it's a OS dependent. OS dependent. OS dependent. OS dependent. OS dependent. Simple answer is like this. That's it. Very simple answer. Why exe file is OS dependent? Simple reason, it contains OS library. Reason, it contains OS library. It contains OS library. That's simple reason. Why exe file is OS dependent? Reason, it contains OS library. That's it. This is about exe file. This is about exe file. Now let us come to Java. Now Java, what is happening in Java? Okay, same concept. Let us start Java here. Java is independent of platform. How Java is made as independent of platform? Yes, in Java, what is happening? Let us see. Java. What happens? Same example, Java. Let us take Java. This example, Java. Let us take Java example. Java. See, Java program. Yes, in Java program, this is a dot class. Yesterday discussed dot class, right? Dot class file. Yes. So Java program dot class file. Java program dot class file prepared on Windows OS. Okay. Then it contains what? Okay. Then it contains what here? Okay. See Java program. See Java program dot class file prepared on Windows OS. Then it contains here binary code. Not binary code. It's byte code. Byte code for Java program. Byte code for Java program. Byte code for Java program. Yes. Next. Byte code for Java library. Like C language in Java also library is available here. Byte code for Java library. Byte code for Java library. Byte code for Java library. Next plus binary code for Windows OS library. No, this part no. Yes, don't have that. It won't link. It won't link OS library with dot class file. Okay, so dot class file. So dot class file. Yes, contains byte code for Java program. Byte code for Java library means it's a pure Java program. Java library also developed in Java. Java library also developed in Java. Okay, so dot class file. So dot class file. Yes, is a pure Java program. Pure Java program. Pure Java program. Pure Java program. Pure Java program in byte format. In byte format. Byte format. Okay. Yes, it don't have any OS library. It don't have any OS library. Any OS library. It don't have any OS library. It don't have any OS library. Okay. Yes, it is free from OS library. Okay. Java program don't have any OS library. Java program don't have any OS library. Yes, it is free. It is free from OS library. It's free from OS library. Free from OS library. Free from OS library. That is simply dot class file. So dot class just it's a pure Java program. Yes, don't have any OS library. It is free from OS library. It is free from OS. Don't have any OS library. Okay. Suppose for example here. For example here. Tested dot class. Tested dot class. Prepared on anyways. Okay. For example, tested dot class file prepared. Tested dot class file. Tested dot class file prepared on anyways. Yes. Yes, it don't have anyways library. It don't have anyways library. Okay, simply plain dot class file. Okay. Yes, tested dot class file prepared on anyways, but don't have. Yes, but it don't have any OS library. Now this tested dot class file on different platforms. Tested dot class file on different platforms. Tested dot class file on different platforms. Let us see. Tested dot class file working on different platforms. Tested dot class file, yes, working. How it's working on different platforms. Okay, let us see. Let us take same different platforms. Tested dot class file on different platforms. Tested dot class file on different platforms. Let us see on different platforms. Tested dot class file on different platforms. Okay. So tested dot class file. So tested dot class. Now tested dot class file. Yes, placing on Windows OS. See tested dot class file. See tested dot class file in different platforms. Okay, first of all, tested dot class file or tested dot class file in Windows OS. Yes, how it's working. Tested dot class file on different first of all Windows OS. So tested dot class file placed on Windows OS. Yes, how it's working here. Yes, this tested dot class file has to run. Now, can I run this tested dot class file directly? No, directly we can't run. Directly cannot be run. Reason here, reason, see, every program, every program has to link with OS library. That link should be there. Every program has to link with OS library before going to start execution. It has to link with OS library. But yes, but a test dot class, yes, nowhere linked. It's not linked. Then how it executes? No, it can't. It has to link. This tested dot class, this tested dot class file, this tested dot class file has to link with Windows OS library. Who will link it? Yes, to run tested dot class file, to run this Java tested dot class file, this tested dot class file has to link with Windows OS library. Who will link it here? Directly we cannot run. Tested dot class file cannot be run directly. That has to link with Windows OS library. Tested dot class file has to link with Windows OS library. Who will link it? Who will link it here? Yes, for linking purpose here, between tested dot class file, Windows OS, one more layer comes. Between tested dot class file, on Windows OS, one more layer comes. What is that layer? Anyone can you guess it? Between tested dot class file, Windows OS, one more layer comes. Linking purpose. To link tested dot class file with Windows OS library. To link tested dot class file with Windows OS library, one more layer comes. What is that? Anyone can you guess? Can you guess it? Anyone can you guess it? No one? Yes, guys, come on. Simple, very simple. Try to guess it. Something comes, some layer, one more layer comes here. Yes, to link tested dot class file with Windows OS library, one more comes here. So which one comes? Binary, no. Sananandan Reddy. Okay. Yes, anyone can you guess it? No one? No, byte already tested dot class is a bytecode file. That bytecode file linking with Windows OS library, who will link it? Who will link it? That bytecode file linking with Windows OS library. Yes, for this purpose, JVM come to the picture now. JVM come to the picture. JVM come to the picture. JVM come to Java Virtual Machine. JVM stands for Java Virtual Machine. See JVM. Yes, JVM taking tested dot class file. Simply JVM taking tested dot class file and links to Windows OS library. So once linked with Windows OS library, then communicates with hardware, then executes. That's it. Okay. Yeah, JVM converting bytecode to binary code means as a part of JVM, there is an interpreter. In JVM, there is a one more interpreter is there. JVM, some interpreter, that interpreter converts bytecode to binary code. In JVM, there is an interpreter. That interpreter converts to bytecode to binary codes. Okay, about JVM we'll discuss. Wait. Yes, see. JVM means JVM stands for Java Virtual Machine. JVM, Java Virtual Machine. Java Virtual Machine. Yeah, this is JVM topic. We have separate topic on JVM. In JVM, there is an interpreter, Java interpreter. This interpreter converting bytecode to binary code. This interpreter converts bytecode to binary codes. Okay. Yes. No JVM. Okay. What is exactly JVM? We'll discuss next. Okay. JVM means JVM. Just imagine JVM means this is one machine. JVM means this one program. Just imagine some program. Okay. JVM is one program. Just imagine like one program. JVM is one program. Okay. Yes, like a Java compile, JVM is one component. Okay. Now JVM. So JVM taking tested dot class file. JVM is just one kind of program. JVM also program. JVM is one kind of program. JVM is one kind of program. Okay. Yes, let me explain. You can understand slowly. Let me explain. You can understand slowly. See, JVM taking tested dot class file. See tested dot class file. Tested dot class file placing an Windows OS. When tested dot class file placed on Windows OS here, Windows JVM taking tested dot class file links with Windows OS library. Once linked here, executes generating output. That's it here. So next, same tested dot class file on another platform. Let us take one more platform. One second. Yes, another platform. Let us take another platform. Linux platform. Linux base with the Linux library. Okay. Yes. See, same test dot class file. Moving on to Linux base. After moving on to Linux base, on Linux base, this is JVM. Windows JVM, this Linux JVM. Yes, Windows JVM, this is Linux JVM. Okay. So now Linux JVM taking test.class file links with Linux base library. See, 1 minute. Test.class file generated, right? The test.class file first time running on the Windows OS. So Windows JVM taking test.class file linking to Windows OS library, then generating output. Fine. Same test.class placing in another OS, Linux base. Now Linux JVM taking test.class file linking to Linux OS library. So what is happening here? That link is changing, right? Depends on ways that link is changing. It's a dynamical linking. That link is changing. It's a dynamical linking. Okay, see, tested.class file, if it is running on Windows OS, links to Windows OS library. Same tested.class file, if it is running on Linux OS, links to Linux OS library. Okay, suppose one more. Let us take one more platform here. One more platform. Yes, Unix platform. Yes, if it is Unix platform. If it is Unix platform here, Unix platform, Unix platform, Unix base with Unix library. Now same thing, same test.class file, same test.class file. Now linking with Unix OS library here. So whenever OS changes, that link changes. So every time of changing OS, that link is changing here. Yes, test.class file running on Windows OS links to Windows OS library. Same test.class file, if it is running on Linux base, links to Linux base library. Same test.class file, if it is running on Unix base, links to Unix base library. That link is changing dynamically. That link changing, see here, link is changing means dynamically. At runtime that is changing here. So dynamically, okay, so dynamically changing that link here. Link is not a fixed. See, previously exe file, our test.exe file. At the time of generating exe file itself, links with OS library. Linked at the time of generating exe, that exe file contains OS library. Yes, here exe file contains OS library, already linked. Okay, exe file contains OS library. Yes, linked with OS library. Okay, that exe file place here. Call to Windows library. Same exe file place here. Already linked. It won't link once again here. Already linked. Test.exe file already linked with Windows OS library. Call to Windows OS library. Okay. So test.exe file always call to Windows library. Always call to Windows library. Always call to Windows library because it's that link is fixed. That link is fixed means statically linking. Statically means fixed. Static means fixed. Dynamic means changes. Okay. See, in physics you will see terminals like static behavior and dynamic behavior. Static behavior means always same. Never changing behavior. Static means fixed. Static means fixed. Dynamic means depends on situation that behavior changes. Static behavior and dynamic behavior. Static means fixed, always same. Dynamic means that behavior changes. Depends on situation, it changes. That is dynamic. Static and dynamic meaning here. Static and dynamic. Static means fixed, never changes. Dynamic means changes. Changes accordingly. Changes accordingly. See, in case of exe file here, yes, exe file linked with Windows OS library. So always it will try to call Windows OS library only. Always it will try to call Windows OS library. On Windows OS called to Windows library. On Linux also called to Windows OS library. On Unix also called to Windows OS library. Always it will try to call Windows OS library because static linking. But when come to Java.class file, what happens here? Java.class file don't have any OS library. Java, it don't have any OS library. Java.class file, it don't have any OS library. It's free from OS library. It is free from OS library. It is free from OS library. Plain dot class file. See, dot class file won't have any OS library. Okay, so dot class file, when you placing on Windows OS here, dot class. When it is moving on to Windows OS here, Windows JVM taking dot class file links to Windows OS library. Same dot class file. If you're placing a Linux OS, then Linux JVM takes dot transfer links to Linux based library. Okay, same dot transfer. If it is Unix based, linking with Unix based library. That link changes. Yes, runtime here dynamically. Okay, link is not a fixed one. That is changes means dynamically here. Dynamically linking. So you get dot plus file dynamically linking with yes OS here. So you get JVM takes care of linking. JVM takes care of linking dot class to yes different operating systems. Depends on ways that link changes. Depends on ways that link changes automatically. So this is called as dynamical linking. Okay. So you get Java dot class file dynamically links to the OS. Since dynamical linking, it's independent platform. That link changes here. Okay. So since its link changes at runtime here, it's a independent platform. Okay. See, Java dot class file. Okay, Java dot class file. Yes, links to yes OS library, dynamically, dynamically, dynamically. Okay, yes. So here Java dot class file, links to OS library dynamically, yes, by the JVM, dynamically by the JVM. Okay, yes, since linking to operating system library dynamically, it's an independent platform. So whenever OS changes, that link changes. Every time of changing OS, that link changes. If OS is Windows OS, dot class for links to Windows OS library. If OS is Linux OS, then dot class for links to Linux OS library. Yes, if OS is Unix OS, linking to Unix library. So dynamically linking, it's a dynamical linking. Java dot class file. Okay, see, since dot class file, we are dynamically, since dot class file dynamically linking to OS library, yes, OS library, yes, it's an independent of OS, it's an independent of OS, that's it here. Since dot class file, dynamically linking to OS library, it's an OS dependent, OS independent, it's an independent of OS. That's it. Now here question is here some doubt here. Maybe somebody some doubt. JVM, is it part of OS? Yeah, that is question definitely. See, on Windows space JVM is there. On Linux space JVM. Yes, Unix space JVM. JVM, is it part of OS? No. JVM is not a part of OS. JVM is not a part of OS. JVM is not a part of OS. JVM, Java Virtual Machine. JVM, Yes, he is not a part of OS. He is not a part of OS. Okay, he is not a part of OS. Then how to get JVM here? Yes, JDK installed. Once JDK installed, getting JVM automatically. Okay, yes, JDK, yes, JVM from the JDK here. JVM from the JDK. Okay, so JVM from the JDK here. Okay, yes, to get the JVM, yes, JDK has to install. JDK has to install. JDK has to install. Yes, install on system. JDK should be installed here. Okay, yeah, to get JVM, yes, JDK should be installed. JDK should be installed. So once JDK installed here, JDK should be installed. JDK should be installed. Once JDK installed, you can get JVM. That's it here. Okay. So JVM is not a part of OS. JVM from the JDK. Yes, in order to get JVM, JDK software should be installed here. The JDK should be installed. Once JDK installed, once JDK installed, you can get JVM. That's it here. Okay. Next. So here JVM is not a part of OS. JVM is not a part of OS. Okay. JVM from the JDK software, Java Development Kit. So once the JDK software installed, getting JVM. To get JVM on this first, you have to install JDK. See JDK. See, this is JDK software. So once JDK 8, JDK 9. Suppose once installed JDK 8, this 8 software here. Once JDK 8 software installed here, getting JVM automatically. On Windows OS, you have to install JDK. On Linux OS, you have to install JDK. On Linux OS, you have to install JDK here. So once JDK installed, you can get the JVM. That's it. Okay, JVM is not a part of OS. JVM is not a part of OS. It is from the JDK. For JVM purpose, you have to install JDK on every OS. Otherwise, you cannot get JVM. That's okay. Fine. Next, one more here. See, tested.class. Java program is a independent platform, right? Java program is independent platform. The tested.class for Java program is independent platform. But JVM is a OS dependent. Okay. Java program is independent of OS. Java program, same test.class file running on different platforms. See, the same test.class file Windows OS, Linux OS, Unix OS. Same .class file running on different operating systems is a independent of OS. But JVM is a OS dependent. Reason. JVM is a OS dependent. Reason. JVM is a C++ exe file. JVM is an exe file. JVM is an exe file. JVM is an exe file. Let me show the JVM also. Yes, program files, Java, JDK. In JDK, here this is JDK bin. Here this is JVM. See, Java application means the exe file. This is JVM. Okay, this is JVM. The program JVM exe files application. It's exe file. Okay, it's exe file. See, .exe file. .exe. JVM is exe file. It's a C++ exe file. JVM developed in C++. Yes, even that also I'll show. Yes, when you're running Java program, behind of Java program, C++ program running. How that C++ program is running, working, that also with memory map I'll explain. Going forward in programming here, whenever you're running Java program, behind of Java program, JVM working. JVM developed in C++. How that C++ program is working, if that also I'll show. Practically I'll show going forward. I have that much of knowledge. Okay. So basically at the beginning, I was a embedded C developer. See, because of embedded C knowledge only here, I'm able to explain all of these things here. See, just simply Java trainer, they can't explain this kind of things here. They must have the exe file knowledge to explain all of these things. To explain today's topic. To explain this today topic here, exe file knowledge, OS file knowledge, JVM knowledge, Java knowledge, compiler knowledge, interpreter knowledge, all this. Okay. Yes, if the trainer is having all this knowledge, he can explain. Yes, because of I have this much of knowledge. I'm able to explain very clearly. This is okay. So this is the reason. So JVM is a exe file. C++ exe file. JVM is a OS dependent. Okay, JVM for Windows OS, JVM for Linux OS, JVM for Unix OS. Different JVMs developed for the different operating systems. Different JVMs developed for the different operating systems. See, Windows JVM can understand Windows OS. Linux JVM can understand Linux OS. Yes, Unix JVM can understand Unix OS. Yes, it has to understand OS. Otherwise, how it can link? See here, Windows JVM is having knowledge of Windows OS. Windows JVM. Windows JVM is having knowledge of Windows OS, so it can link tested.class file with Windows OS library. See, to link with Windows library, this JVM must have knowledge of Windows OS. Otherwise, how it can link? It cannot link here. So Windows JVM is having knowledge of Windows OS. Linux JVM is having knowledge of Linux OS here. Yes, Unix JVM is having knowledge of Unix OS. With that knowledge, it can link to library. That's it here. Okay, so JVM is a OS dependent. It's a C++ exe file. Okay, see, JVM is a OS dependent. Now here, 1 second. Suppose yes, JDK. So this is Windows JDK, right? The same JDK can I install with Linux OS? No. JDK changes from OS to OS. Same JDK cannot install on different operating systems. Cannot. Reason, JVM OS dependent. JDK contains one JVM. This JDK contains JVM. That is OS dependent. Since JVM is OS dependent, JDK also OS dependent. Different JDKs for different operating systems. Same JDK cannot be installed on different operating systems. See here, this JVM. Okay, this JVM exe file. That JVM exe file is a OS dependent. Okay, different OS dependent. Okay, so OS dependent. OS JVM is a OS dependent. Okay, so Windows JDK has having Windows JVM, Linux JVM, Unix JVM. So JDK changes. Same JDK cannot be. So same JDK cannot be installed on different operating systems. See this. Let me show that. Yes, same JDK cannot be installed on different operating systems. Yes, download. Yes, JDK 1.8, for example here. See, JDK 8. See 8. See here, 8 from the Oracle Corporation. From the Oracle Corporation, see, JDK for Linux OS. See, JDK for Linux this is. Okay, JDK for Mac OS, JDK for Mac OS, JDK for Solaris OS, JDK for Windows OS. Yeah, this is last one. Yours is the last one. If you're working on Windows OS, you have to download this one. You have to download last one. Suppose if it is MacBook, okay, if it is Mac, you have to download this one, Mac OS, Mac software. Okay, you have to download separately here. Same JDK cannot be installed on different operations. JDK is also OS dependent. Since JVM is OS dependent, JDK is also OS dependent. That's it. Okay, so that's the reason Java is independent platform. See here, yes, how Java made us independent platform. Behind of this reason is like this here. Okay, see here. Java.class file is not linked with OS library. Java.class file don't have any OS library. Yes, it's a free from OS library. Java.class file. Since Java.class file dynamically linking to OS library, it's an independent platform. JVM takes care of that linking here. Okay. So when every time of changing OS, that link changes. Every time of running here, link changes. Yes, OS changes, automatic changing link here. Whenever OS changing, link changes. OS changes, link changes. That JVM takes care of linking here. So that's the reason Java is independent platform. Yes, like this, Java made us independent platform. I think everyone you understand, guys. How Java made us independent platform. Is it clear? This is reason behind of this. I think everyone you understand clearly. Yes, how it is made as independent platform. Okay. Yes, is it clear, guys? Hello. Please respond. Yes, how Java made as independent platform? Rationalists. I think very clearly understand this is. Yes, see, 1 second. Yeah, this kind of explanation nobody will explain, I'm sure. Because no Java trainer don't have this much of knowledge. Okay. With the Java knowledge only, no one can explain. To explain all these things, compulsory embedded C knowledge. Embedded C knowledge must have, OS knowledge must have. 1 second. See here, independent platform. Today we have started independent platform explanation. Today explain about independent platform, right? Actually here, to explain this, yes, prerequisite 2 classes I have explained here. Yes, why that all the basics. From the basics I have started here. From the basics. From the basics started. About voice explained here. About voice explained here. Next about yes, about interpreter compiled explained. Next about Java compiler explained here. About exe file dot class file explained here. After finally presented independent platform. Finally, after explaining all that prerequisites, finally presented independent platform. See, last 2 classes is a prerequisite for the today class. That's the reason explain all the basics. About voice explain first. Next about interpreter explain. About compile explain. About exe file explain. About dot class file explain. After finally presented independent platform. That's it. That is my way of explaining. Okay. Generally here, most of the trainers, independent platforms, they will explain within 10 to 15 minutes, they will go to next topic. 10 to 15 minutes explanation, just independent platforms, simply they says that, yes, Java is independent platform, means Java is independent of operating system. Same program running on anyways. Behind of that, JVM is a reason. Simple expression. Okay, they says that JVM makes the Java is independent platform. JVM, yes, taking dot class for running on different platforms. Simply they will explain like that. That's it. That is the difference between me and others. Okay, that is experience. Okay, whatever the experience I have, just I'm presented. Just that's it here. My experience, just I have presented. Okay, see, forever class, nothing to prepare extra for me. Yes, forever class, nothing to prepare extra for me. I have the knowledge, same knowledge I'm explaining. That's it here. Okay, yes, fine. Yes, now here, see, exe file and dot class file, what's the difference? Let us see. Now we can understand very clearly. Now let us compare this. Exe file versus dot class file. Exe file and dot class file. 1 second, just a minute. Just a minute. I'm taking some water. Just a minute. Yes. Now see that exe file dot class file, that comparison. See the comparison. See exe file. It's a binary code file. Exe file, it's a binary code file. It's a system understandable language. Exe file, it's a binary code file. It's a binary code file. It's a system understandable language. What is dot class? Dot class is a bytecode file. Yes, what is bytecodes? Yes, we'll discuss. So when come to actual Java programming, I'll show bytecode. Bytecode contains exactly what. That also we'll discuss. I'll show one day bytecode, like binary code. Just now I showed binary code on Linux base, right? On Linux base, I showed binary code. Similar way here, I'll show bytecode also. Okay. Yes, in Java programming, I'll show that. Okay. See, it's a bytecode file. Yes, dot class file, it's a bytecode file. It is a JVM understandable language. It's a JVM understandable language. See here, bytecode. See exe file. Exe file is a binary code file. It is a system understandable language. Bytecode file is a JVM understandable language. JVM understandable language. Okay. See next difference. Exe file, which contains program code, software library and OS library, including OS library, exe file including OS library, dot class, pure Java program. Dot class is purely Java program. Don't have any OS library, don't have any OS library, don't have any way. This important point. Don't have any OS library. Even Python script also same. Python script also don't have any OS library. Python links to a different operations at runtime. Python also dynamic linking. Python scripting also dynamic linking. Suppose Python script is running on Windows OS, links to Windows OS library. Same Python script running on Linux OS, links to Linux OS library. Same Python script is running on Unix OS, links to Unix library. For the Python interpreter. Python interpreter takes care of linking Python script to with different operations. Same Python interpreter also OS dependent. Windows Python interpreter for Windows OS, Python interpreter for Linux OS, Python interpreter for Unix OS. Depends on OS. Even Python interpreter also changes here. Same Python software cannot be installed on different operations. Python software OS dependent, but program is independent of platform. Python scripting is independent of platform. How? Dynamic linking, like a Java, Python also dynamic linking to OS. Since dynamic linking to OS, that is also independent of platform. That's it. Okay. Yes. See here, any language, if it is exe concept is there, any language, if it is exe concept, that is OS dependent. If don't have exe concept, that is independent of OS. Any language, exe concept is there, that is OS dependent. If it is exe based, any language exe based, it's a OS dependent. If it is non-exe based, that is independent of OS. Okay, fine. Next, see here, exe file contains OS library. Yes, dot class file, pure Java program. Don't have any OS library. Okay. Yes. Next here, see exe file. Exe file prepared for specific OS. Exe file is prepared for specific OS. Okay. Dot class file is not a prepared file. Don't have any OS library. Okay. Dot class is not a prepared file. Okay. Exe file is prepared for specific OS. Okay. Yes. See OS library. OS library statically linking with exe file. OS library statically linking. In case of dot class file, OS library dynamically linking with dot class file. So this is static linking, this is dynamic linking here. Okay. Yes. Next exe file. Exe file is already prepared one. Okay. Before running an OS. Exe file already prepared one before running an OS. Means statically linking, already linked and running. Okay. Dot class file is not a prepared. That is not prepared file here. After moving on to OS, after placing an OS here, JVM prepares as per current OS. JVM preparing means dot class for linking with current OS. That linking is nothing but runtime preparation. Preparing at runtime here. So linking to current OS. Okay. That linking happens at runtime. But exe file is statically linking. Already prepared one. Already prepared. Dot class is not a prepared. Okay. Yes. Next difference. See, exe file executes faster than dot class file. Exe file executes faster than dot class file. Reason, exe file is already prepared, directly running. Again, preparation is not necessary. Linking with OS library is not necessary. Already linked exe file at the time of creation of exe file itself. At the time of creation of exe file itself, already linked. So complete preparation is done. Complete preparation is done, directly execution. It won't take any time to execute here. It won't take any time. But when complete dot class file, since dot class file preparing at runtime, so dynamically linking dot class file, every statement line by line linked to OS library, then running. Linking running. Yes, since it's linking at runtime here, it will take some time here. It will execute slowly than exe file. Okay. Next, one more important point here. See, to run exe file, application software not required to install. What does it mean here? To run exe file, application software not required to install. What does it mean? See, Linux base. See here, the project exe file prepared. See, on Linux base, C software installed. GCC is a C compiler. Yes, here installed. C compiler. C compiler available, installed, C software installed, and exe file prepared. Now running that exe file, on the site. Now same this exe file, placing another Linux base. Same that exe file placing another Ubuntu Linux base. Same ways, similar ways, same ways. To run on same ways, again here C software not necessary. On Ubuntu one, C software already installed and exe file created. Same exe file we can move to another Ubuntu, similar ways. Another Ubuntu, you can run it directly. Yes, on Ubuntu 2, 3 and for other machines, again C software not necessary. Exe file is ready-made file. Exe file is prepared file. Exe file is prepared file. Again preparation are not necessary here. On Ubuntu 1 already prepared. Same exe directly can place on Ubuntu 2. Directly can run it. Place on Ubuntu 3, you can run it. Place on Ubuntu 4, you can run it. Because all are same operating systems. The Linux ways. Yes, all are Ubuntu Linux. All are same ways. If it is same ways here, you can run it directly without installing C software. C software not necessary. Without installing C software, you can run it. Suppose if it is Java here, Java. Yeah, to run Java program here, yes, running Java program, to run the Java program, every system must have JVM compulsory. And every system must have JVM. Without JVM, you cannot run the Java here. Suppose .class file prepared on Windows base. Move to same Windows base. Even move to same Windows, that Windows system also must have, yes, Java software. Yes, .class is running by the JVM. Yes, .class is executing with JVM. Okay, that way that OS must have JVM. Yes, even Linux OS JVM. Yes, every OS must have JVM. How to get JVM? JDK. So without installing JDK, you cannot run the Java program. Okay, without installing JDK to run the Java program. So a Java program already prepared. Even .class file prepared here. Yes, still, yes, we need JDK software. The JDK software you have to install. Without installing JDK software, you cannot run Java program because JVM requires. Okay, Java program running by the JVM. For the purpose of JVM, you have to install JDK software. And every ways you must have JDK software. Okay, even same ways, you must have the JDK software, otherwise cannot. But when come to exe file, once exe file prepared, on Ubuntu one exe file prepared, same exe directly can run. And second Ubuntu C software not necessary. Next Ubuntu C software not necessary. That application software is not necessary. That is exe file. Okay, to run the exe file, that application software, C application software is not necessary. Okay, to run .class file here, JDK should be installed on OS, otherwise cannot here. So this is difference. Exe file and .class file difference is that. Okay, see, first already we discussed about exe file and .class file. Just I have compared now. First we have discussed about completely about exe file. Next discussed about .class file. Next just compared for easy understanding purpose. Yeah, that's all about exe file .class difference here. Okay, see you guys, just you try in net in Google, just you try for difference between exe.class file. You'll get only 2 points. Only 2 points. Exe file is binary code file, OS dependent. .class is byte code file, yes, independent from only 2 points you'll get it here. Yes, no website will give this much of information. I'm sure it's my challenge also. No website will give this much of information. Okay, my knowledge, my experience is more than the industry. Even Google also sometimes cannot reach my knowledge. That is my knowledge and my experience here. 20 years of experience traveling in software field. Java, embedded C, OS, Linux OS, and Hadoop and big data, various kind of things I'm working here. Okay, see, since 20 years I'm working as a technical guy. Yes, I got the promotion to work as manager for many times, but I did not agree. Okay, many companies offered for manager job. Yes, our company offered but I did not accept because my interest is technical interest. Because what is project management? Just is a man handling, just manpower management, resources management. Project management is nothing but resources management that anyone can do. Why strong technical skills not required? Okay, I want to be technical guy. Lifelong, I want to be a technical guy. So I have promoted as only architect. Okay, I want to be like architect. That's it. I don't want like manager. See, my salary is more than my manager. Okay, architect, my salary is more than my manager. Okay, that is interest. That's it. Coding and technical skills and these are all that interest. That's it here. Okay, that interest, because of interest only, I'm in this coding area. Okay. Yes, so this is about exfl class independent platform. This is Java introduction. Okay, all that introduction completed. Okay, next topic is installing Java. How to install Java? Installing Java, installing Eclipse, and writing first program. Okay, Java installation. Next topic is yes, installing Java. So next topic is this. You guys open the documents, read all the topics here. Yes, about compiler interpreter. Yes, exfl dot class. Till now, what I discussed, everything is the document here. Just you follow document here. Open documents, read the documents. Yes, for many guys, almost in your batch, 20 members are attending. Out of 20 members, yes, I think 16 to 17 members paid fees and joined into batch. Thank you guys. Thank you all for joining to this batch. Okay, almost yes, 16 members paid. Yes. By today class here, almost 15 to 16 were paid here. I think 2 or 3 guys are there. No problem. Okay, no problem. I'm not a commercial. Yes, no problem. Okay. Yes, pay it ever convenient. No problem. Okay. Yes. So almost all shared this document. Suppose if anyone not received document here, yes, maybe the payment I think may not be paid here. Okay. Yes, of course, still I'm giving support. Yes, daily class session I'm sharing in a WhatsApp group. See, in WhatsApp group, I'm sharing. Okay, let me show that group. Yes, I'm sharing the WhatsApp group. Yes, daily class notes I'm sharing, daily video also I'm sharing here. Okay. Yes, daily class notes I'm sharing, daily video I'm sharing here. Okay. Yes, first 3-4 days I'm sharing all this. Next, who paid for them drive access given directly? Drive access given, they are able to see the videos and documents and everything here. Okay, who not paid for them? Yes, the group I'm sharing. Now currently I'm sharing the group. Okay, yes, still anyone to yes share your details, please share it. Okay, WhatsApp group. 1 second. So this is your group. Yeah, 530 group. This is group. See in that group daily information. Yes, it is. Session for yesterday session shared. Okay, daily class documents also sharing. Yes, the day one, see day 1, day 2, day 3, daily class documents. Okay, now for the time being, just you follow WhatsApp group here. Okay. Yes, for all these daily videos. Yes, I think almost all guys got the drive access. Okay, they are able to access from drive also. Class notes and document, everything they are accessing from the drive. Still anyone pending are there to share our details, please share here.